All right, hello students. Today we're moving on with lesson 7, distance on a coordinate plane. So we have this picture here. This picture actually probably be at the bottom of your page. And as you can see, I've kind of cut off the table. I'm going to go through a few of them with you and have you try a few on your own. And then we're going to kind of do that a couple times. And then, of course, you'll have a short little assignment based on what we talked about. All right, so let's go ahead and look at what's going on here. So determine the length of the given line segment by determining the distance between the 2 points. And here we have line segment AB, BC, and so forth. And we have 1 point, a second point, the distance, and then the proof for how we came up with it. And then, of course, here is what we're talking about. So line segment AB starts with A up here and goes across to B. So this is line segment AB. So first we want to determine point A and then determine point B. Well, point A is over to the left 2, so that's -2 and goes up 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8. So let's go ahead and label that in there. Oops, sorry, my box got off a little bit. All right. So go ahead and go point A. There you go. And then, of course, I said -2 to the left and then +8 going up. And then, of course, we have B. B, it looks like it goes over, remember, starting from the origin, it goes over 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it goes over 9 in a positive direction. And if you notice, these are equal to each other. So it goes up to 8. So let's go ahead and put that in there. And now all I have to do is determine the distance. Well, one of the things we did talk about, I believe we have talked about, is kind of figuring out the distance simply by counting these. So if we count here, there's 1, 2, and then there's 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this would have a distance of 11. I think all my boxes are going to be off, so I'll have to fix those. So this is a distance of 11. And so we should put units there. Sorry, I forgot to put units. Just put the lowercase u would work. So 11 units is a distance. But now we're going to talk about how we can prove this. We can't just simply write counting. We got to prove this mathematically. Well, if you kind of notice or think about what we did, first we counted from A to the y-axis, or to 0. So we counted over 1, 2. And then we kept counting to B. So if we talk about kind of the distance A is from the y-axis, or 0, and the distance the B is from the y-axis, or 0, that would help us come up with the proof. Well, we also should notice that both y values are exactly the same. Because these y values are the same, these are kind of meaningless when it comes to distance. And what's the distance between 8 and 8? 0. There is no distance. They're the same number. So what we're talking about is the distance of the two different numbers. In this case, it's our x value of -2 and +9. So if we're talking about the distance A is from 0, of course, it goes over 1, 2 units. This is also known as the absolute value. The absolute value of, oops, I forgot to put the 2 in the middle, but the absolute value of 2, and then the absolute value of the distance B is from 0. So, of course, that's the absolute value of 9. And so we know the answer is 11. Oops, that was a little bit long there, so let me go ahead and erase it real quick. We know the answer is 11 based on our counting skills, but if this was like 1,000 units or something like that, we wouldn't have to count all those. We would want a formula or something to help us with this. Well, remember, the absolute value of -2 is +2. The absolute value of +9 is 9. And so if we add these two absolute values together, 2 + 9 is 11, that works as our proof. So because these are, like we said, on opposite sides of kind of one of the y-axis in this case, or the x-axis if it was going vertically, we just simply add them together. All right, so let's go over another one. Let's go and look at BC. So BC, we already know what B is, so let's go ahead and put that down. B, remember that just because we're changing problems doesn't mean that the numbers for B are going to change. That's still in the same spot. So let's go ahead and put B, and then go ahead and put 9, comma 8. So I really should get my cursor out of the way. Oops. All right, there you go. And now we have C. So C, well, it goes over the same units of 9. As you can see, it's lined up with B. So if B's at 9, C would be at 9. Now how much as it goes up? It goes up 1, 2, so it's a positive 2. And now we want to figure out how many units. Well, this one, the x values are the same. If we notice, they're both x values are y. So we want to know the distance between the 8 and the positive 2. So we can count. There's 1, 2, 3, 4, 5, 6. So we know the units are 6 units. Now let's go ahead and prove it. So let's go ahead and get our pen out. So let's go ahead and prove the distance between these two is 6. Let me click out of this real quick. All right, there you go. All right, so now we need the absolute value of 8 and the absolute value of 2. Forgot to put the line on the other side. And of course, I know this equals 6. Well, now if you look at these two, here's C and B. Both of them are above the x-axis, so they're both on the same side. Or if you look at them, they're both positive. On the number 1, or the first one, they are opposite signs. One's negative and one's positive. So we added. Both of these are the same signs, or positive. That means we subtract them. So 8 minus 2 is 6, and that's how we come up with it. Or the absolute value of 8 minus absolute value of 2 would give us 6. Once again, because we don't want the ones that are the same, we want the ones that are different. Since they're both positive, we just simply subtract the numbers. So now what we're going to do is we're not going to count on this next one. We're going to label the points, and we're going to kind of get the answer by just simply using the proof. And then we're going to count to kind of make sure we did it right. So C, just like before, is the same thing as the same as the problem before. And now we have D. D is right here. So it's still at the x value is still at positive 9. It's on the same line. And now instead of going up 2 units, it goes down 1, 2, 3, 4, 5. So that would be a negative 5. And now we're going to go ahead and we're not going to put the, sorry, let me expand this out. It's not expanding for me. There we go. All right, so now we're not going to put the distance. We're going to prove it first. We're going to do the proof by using the absolute value of the different numbers. So let's go ahead and grab our pen. So now we're going to put the absolute value of positive 2, the absolute value of negative 5. And now, like I said, if we look at these, if they're the same sign in between, we subtract. If they're different, we add. This is negative, this is positive. That means we need to add these two. Absolute value of 2 is 2. Absolute value of negative 5 is 5. So 2 plus 5 is 7. So now let's go ahead and count to kind of confirm. Well, from here, there's 1, 2 to 0. And then there's 3, 4, 5, 6, and 7. So yep, that is absolutely correct. This is 7 units. All right, now what you're going to do is you're going to fill in the rest of these 3. You're going to take a moment. I want you to pause the video. I want you to fill in the points, fill in the distance, and fill in the proof. So I want you to fill in how you would actually solve this, making sure you're using the right symbol, either addition or subtraction. So please pause the video and take care of this. Actually, I'm going to stop the video here. So the second video will go over the responses or the answers to these and move on to the next section.